Hello friends, myself Deepak Dubey. I am founder and CEO of New Pascal Technologies Private Limited, and today I have started a very interesting video series, that is knowledge series on maglev turbine vacuum pump. So as an enthusiast of vacuum industry and vacuum technology, I would like to present series of videos whenever I get the time to educate our customer more about vacuum technology. So today is our first video, and we are going to talk about history and evolution of vacuum technology in industrial sphere. So stay tuned to the last minute of this video, and you'll be getting a lot of information about the history of vacuum technology and how evolution happened from leather bellow to the maglev turbine vacuum pump. Today, if you look at any modern process industry, whether it is steel plant, power plant, or paper mills, chemical factory, or refinery, you will find vacuum pumps everywhere. In some places, they work as a blower. In some applications, they work like a compressor. And in many industries, they are used as a vacuum pumps. But fundamentally, all these machines operate on very similar principle. That is, from one end you are sucking the air, and from other end you are discharging. This simple principle of moving air from one place to another has been the backbone of many industrial processes for more than a century. The journey of modern vacuum technology began during the early industrial revolution. In the year 1850s to 1860s, industries such as iron and steel manufacturing were expanding rapidly. Large blast furnaces were being built to produce iron at massive scale. In order to operate efficiently, these blast furnaces required continuous and powerful supply of air. The air was blown into the furnaces to intensify combustion and increase the temperature needed to melt iron ore. During that time, the air was supplied using very primitive system. Large leather bellows and piston type pumps were used to blow air into the blast furnaces. These machines were slow, inefficient, and required a lot of manual operation and maintenance. Engineers were searching for something very reliable way to deliver large and continuous flow of air. In September 1860s, two American brothers, Philander H Roots and Francis M Roots from Indiana states, that is from USA, developed a revolutionary machine known as Roots Blower. They patented a design that used two rotating lobes placed inside a casing. That twin lobes rotated in opposite direction, trapping air between the lobes and the casing and moving it from inlet side to the outlet side. This simple but powerful design allowed industries to move a very large volume of air continuously. For the blast furnace industry, this was a major breakthrough. Blower quickly replaced leather bellows and piston pump in many steel plants because it could deliver a large airflow with great reliability. Interestingly, engineers soon realized something even more important. If a machine can push air, it can also pull air. In other words, the same technology that blows air can also create vacuum. This discovery marked the beginning of industrial vacuum technology. As industrialization continued, more complex process industries began to develop. Chemical plants, power plants, and especially paper mills started using vacuum in their processes. At that time, dry vacuum machine often faced a serious problem. When moist air or steam entered the machine, condensation could occur inside the system, causing performance issues and unstable vacuum levels. Engineers needed vacuum that could handle large amount of vapor without losing performance. Around the earlier 1900s, engineers at the German company Siemens developed a new machine called the liquid ring vacuum pump. Between 1903 and 1905, this technology began to be used commercially. This design of liquid ring vacuum pump was very clever. Inside the pump, rotating impellers spin inside casing that contains liquid, usually water. As the impeller rotates, the liquid forms a ring along the inner wall of the casing. Because of impeller is mounted eccentrically, this creates expanding and compressing spaces between the impeller blades. And the liquid ring at the expanding side, gas is drawn into the pump. At the compressing side, gas is discharged. Because the sealing medium itself is a liquid, the pump can easily handle moisture and vapor. This made the liquid ring vacuum extremely useful for industries such as paper manufacturing, chemical processing, and power generation. For many decades, liquid ring vacuum pumps became standard solution for industrial vacuum systems. Everything continued to work well until another major event in global history changed the directions of engineering innovation. In 1970s, world faced a severe energy crisis. In 1973, Israel and Arab war, Arab countries imposed embargo on many countries who were supporting Israel. And during this time, energy suddenly becomes very expensive, and industries around the world began searching for ways to reduce power consumption. Vacuum pumps and compressors consumes a large amount of energy, so engineers began developing more energy efficient technologies. Interestingly, a new type of vacuum technology had already been invented earlier. In 1958, a German scientist named Willy Becker developed the turbomolecular pump. This pump used extremely high-speed rotating turbine blades to transfer momentum to gas molecules and create ultra-high vacuum conditions. However, turbomolecular pumps were mainly used in scientific and laboratory applications where very high vacuum was required, but the gas flow was relatively small. They were not suitable for large industrial processes. After the energy crisis, engineers began developing turbine-based vacuum systems that could handle larger volume of gas while consuming less power than the traditional liquid ring pumps. These machines use centrifugal impellers running at very high speed, typically between 8,000 and 15,000 RPM. Instead of using liquid as a sealing medium, they relied purely on high-speed gas momentum. While this significantly reduced the power consumption, it introduced new challenges. High-speed rotating equipment requires precision bearings, lubrication system, and advanced maintenance processes. The system became more complex and expensive. This technology was widely adopted in developed countries like US and Europe, where advanced maintenance infrastructure was available. However, in many developing countries like China and India, liquid ring vacuum pumps continued and dominated due to their simplicity and reliability. The next major breakthrough came with the development of magnetic levitation technology. The concept of magnetic levitation had existed for decades. It was developed in 1930s itself. However, the earlier generations lacked the advanced electronic sensors and control system required to precisely stabilize high-speed rotating machineries. In the early 2000s, companies began using magnetic levitation technology in equipment such as chillers, compressors, and blowers. Especially Chinese government and industries invested heavily in developing these advanced systems. Eventually, around 2018, several companies, especially in China, began applying technology to vacuum pumps. Magnetic levitation turbine vacuum pump represent the latest stage in the evolution of vacuum technology. In this design, the rotor is completely suspended in the air using magnetic bearings. Two radial magnetic bearings and one axial magnetic bearing hold the rotor in the position. High-speed sensor continuously monitor the rotor position and sends tens of thousands of signals per second to a controller, which adjusts the magnetic forces to keep rotor perfectly stable. The rotor is single shaft. On that one part, turbine is attached, and on the center, permanent magnetic synchronous motor is attached, and turbine impellers are mounted on the same shaft. Because there is no mechanical contact, there is no friction, no lubrication system required, and very little maintenance required. The system becomes more compact, more efficient, and more reliable. From leather bellows in 1800s to magnetic levitation vacuum pumps today, the evolution of vacuum technology tells us a fascinating story of engineering innovation driven by industrial needs and geopolitical situations. What started as a simple need to blow air into blast furnace has evolved into one of the most advanced pieces of rotating machineries used in modern industry, and this journey of innovation continues even today. So this was our story about evolution of vacuum technology, how vacuum technology evolved over the period of 160 years. Similar kind of story will be posting more on our YouTube channel. So I would request you to subscribe and like our YouTube channel, The Neo Pascal, and do share this story with your friends and families. Do tell us how you liked about this video. What is your views on evolution of vacuum technology? Stay tuned, we'll be posting next video very soon.